Can I please have you guys introduce yourselves?
I'm Theodore Lindsay.
I'm Israel Camerman.
I'm Fran.
Okay, thank you. And can you please tell me about some of the basic design features of your robot?
Right here we have two motors not facing the outside, so that they can be scooted together as close as they can. We have a rotation sensor for measuring distances. We have a light sensor for finding the flag, one for following a line, and two touch sensors that we use to tell the robot where the flag is, and to tell it, and for it to follow walls.
Okay.
We also have wheels geared down 3 to 1 to make it go slower.
But it also goes strong, or it makes it stronger. We also have cross bracing right here that keeps it together and keeps it from falling apart.
Yeah. And it is also fixes directly on top of them,
Which makes it so that it's also another way to make the robot compact.
yes, compact, robust.
Also, there's a forklift, so you can lift things, and it also these right here can tilt so that you can drop things without lifting them.
How does it tilt?
It tilts along this stationary fulcrum right here.
Can you point that out?
Right.
Oh, I see.
And we are using rubber bands to drive the forklift, so that when it gets to the top or the bottom, the motor it doesn't have to be as accurate, and so that it doesn't burn off. Right. And also it's compact. It's also compact because it's as tight against the R6 as we can get it.
Okay.
Israel, do you want to talk about the two means of traveling?
You can go like this or like this.
And
Yeah.
when it's going like this, it
It is very straight because these two wheels are locked, so it can't turn at all, basically.
and this way it's driving on two pegs.
This way it drives on pegs, as he said, and they'll keep it from falling forward and kind of capsizing it, but it can also turn.
And so that means your problem with this kind of drivetrain is that it's hard to get it to go straight, so that's why we do this thing.
Okay.
Pretty well.
And so if you want to turn and you've got it into the vertical position, are you able to go straight that way?
Well,
We have that device, which takes a long time to put on, but we can take it off quickly.
Can we see that?
First mission.
Oh, you use it on first mission. How does that go on?
It just goes on the back.
Let's see.
On the back.
It has gears that connect with the ground gears on the wheels to block them.
Oh, okay. That seemed to go on pretty well. Okay. And what was it about the forklift? Why do you have that?
We have that to lift and lower like the food and stuff, and
Why did you decide to use a forklift?
because we need to lift it onto a table, so a forklift would be.
It easily alters the height so that you can lift stuff
And this is good for dropping things.
and it's a really compact way to move things around.
Okay. What about the missions? How do you go about them?
Well, for the balls, what we do is we have a little device that latches on to this little.
thing I should point out about that is we're using whole beams rather than axle beams, so that it's easy to take off real quick.
Just pull it on.
Another thing that makes it nice is that we have the alignment device, so that we can always get.
Can we see the alignment device?
We can always start out the robot at the same point.
It has screws and things on here to keep the robot straight when it's on it. This fits into that corner, and to make sure our angle is consistent, we have the old 60s here, and we set it up so this marker is a certain pair.
Can you turn that this way? On the table's easiest to see. Okay?
Well, the way the robot goes about doing this program is it starts from base, and it rolls forward, and as it stops here, and this thing pushes forward, which
Ball rolls down
the
there,
ball rolls
makes it
down.
more accurate than dropping.
Okay. And which of your programs are you pretty proud of that interacts with the robot?
The really nice one is the gate one. It involves,
Can't get to,
it takes,
Do you want to show us?
we have two programs for
Is it
that.
towards the bottom there?
Right. We have two programs for it. One is finding the flag, and one we're telling it where the flag is. When it finds the flag, it uses the light sensor.
and where we tell it where it is, we do that by pressing one or both of the determinant.
Okay.
The way it does it is
Thank-
just walks down, follow the line until it gets to the spot where the flag should be, spins to hit it, then it drives along until it gets to the wall, which is really easy, accurate because it often, even if the rotations are different, it doesn't depend upon rotations. And it backs up against the wall to make it so that it is extremely accurate.
And stuff you could things demonstrate, because if it's like this, it drives both motors backwards, so that both wheels are up against the wall, and that's supposed to be pretty good.
And then it's directly opposite the gate, so it goes forward, and this is on,
So it's supposed to move over.
but it goes on, and then this, it
Catches on the gate.
it catches on the gate and pulls it open. And then if it doesn't catch on the little
Lock.
lock, this
Puts this side
turns,
in.
this turns, hits it like that to make sure it goes, and then it goes through and drops the boot.
That's where we use the.
And then we pick it up and pick it back.
Okay.
The reason we pick it up so that it just takes a lot of time.
Although
Okay.
actually we do have 45 seconds to spare, so you don't need to do that.
However, I think that the coolest program is the stairs, because we have the nice little DEQ thing.
Here's
And
the,
that was probably demonstrate.
What happens in this is the robot goes onto a big platform that has rubber bands, and it goes backwards, so these wheels go forward, and then this is to sweep out any chairs that might be there.
Except we have referees move that now. Currently we just use it to aim it.
And what happens is, it goes forward, this hits the stairwell, and
the robot reserves.
the robot hits it, and that activates the touch sensors, and so then the robot starts going forward and rolling over the edge.
Good thought.
And pushes this down.
And then this springs up, usually, and it's very nice and tight.
The way we do this is, when the robot drives, it has to drive the wheels backward to push these forward. And it has these ratchets that catch on the gears, so that when the robot drives backward, it doesn't, the thing can't go backwards. We also have these posts to keep the robot from driving off the base.
Because it's trying to drive in that direction. So do this. Another pretty cool program is the one that CD controller.
Now, the interesting thing about this is programming for it. You tell it whether or not to do the glasses by whether or not we press the touch sensor. So here it is. And it works.
That's not as many points as you could possibly get from CD. It did in, I think,
5 seconds.
18 seconds, including the time it takes to put that on and everything.
One really is it has a huge margin of error, so that if the robot comes along and it catches on the thing, it still flicks it off. Or if it goes like this, it'll also drive it on.
Like
And it's fast.
so, if it goes straight, it'll just,
There.
and it'll go straight, and go straight. Now there's an axle on the ones as well. And then it off in the same way.
Are there any other,
We have to demonstrate.
Here's,
Just all the interesting things.
the food thing, which is, the nice thing about it is it combines two attachments into one, so you can set this on the attachment, and it can raise and lower on the forklift. And then it also works for the glasses, because these catch on the glasses when you drive by like this. This isn't the glasses, but
It drives by.
so do your, missions rely more on the, robot, or they rely more on the program?
Probably the program.
for the gate, it really relies on the programming, because the rope's pretty much the programming for it. But like the stairs, it really relies on the robot.
And this is also all hardware based.
Okay, are there any final thoughts you have? You pretty much covered it all?